2.1.1, if we look at the question paper here, it's asking us to solve the following algebraic equations. So I've got the first one on the right here. So this is a straightforward linear equation, and it can even be solved just using inspection. In other words, what plus 7 gives us 13, and of course the answer is 6. Or we can use, of course, we can use the inverse operations, or taking the numbers to the right basically. So if I take the number to the right, so if I take 7 to that side, the sign of 7 will change to a negative. So it will essentially become 13 minus 7. So if I write that out, I've got A, and if this guy goes that way, then I've got 13 minus 7, A is equal to 6. 2.1.2, we have 3x minus 1. This is an x here. 3x minus 1 is equal to x minus 7. So here we can use inspection if we want, if you just play around a bit with the numbers, but I really want you to get into the habit of using inverse operations to manipulate this equation so that you can isolate the unknown letter or variable and solve for each value. So what we essentially are doing in a case like this is making sure all our letters are on the left and all our numbers are on the right, and we do that by moving them from the one side to the other. In other words, I want my letters on this side and I want all my numbers on that side. So, and when I move them, the sign must change from whatever it was. So if we apply this rule, this method, I want, of course, 3x is part of the letters and it's already in the right place, it's on the left hand side, but I want my x that is on the right hand side, I want it to be on the left hand side. So currently my x is a positive x. Although you don't see the plus sign there, the fact that there's not a negative means it's a positive. So if I move this guy here, its sign will become negative. Okay, so that means minus x. Then for the number 1 or negative 1, here you can clearly see that this is a negative 1. So if I'm going to move it this side, it will become positive 1. The negative 7 that was here already, it does not change sign, it stays negative 7. So I've got negative 7 that was there, and I'm now going to say plus 1. So the sign changes that took place here was the negative x and the positive 1. Simplifying this, we have 3x minus x gives us 2x. And please use your calculator. Okay, we know that you have challenges adding integers, especially when there's negatives involved. So negative 7 plus 1 is negative 6, and if you are uncertain, please just use your calculator. So negative 7 plus 1 is negative 6. I think also the problem with learners still making mistakes with these kind of calculations is the fact that, and I think this is even more dangerous, you think you know how to do this in your head, and then you don't, and you do that, you write the answer, which is wrong. You never bother to check with the calculator, and then you lose unnecessary marks. So the fact that you don't know is more dangerous. So that's why I've said repeatedly, please just use a calculator to do these calculations, especially if you're uncertain. Right, then at this point here, we've got now 2x equal to negative 6. So in order to get rid of the 2, remember the 2 is connected to the x via multiplication. So if I want to get rid of it, I must not subtract 2 because that won't do anything. I can't subtract 2, but I can divide by 2. But I must do it on both sides. So that means doing this will result in the 2's cancelling out, cancelling in inverted commas, and that will leave me with x, and negative 6 divided by 2 is negative 3. 2.1.3. This problem on this type of equation has been a bit of a pain, simply because for some reason we cannot remember that seeing something like this means I've got a number or a term outside the bracket being multiplied with a bracket. Inside the bracket I've got 2 terms. So this is where I apply the distributive property. So that allows me to get rid of the bracket and expand the bracket, expand the terms. And I of course can do the same thing here. Okay, there's nothing complicated about applying that rule or that process. If we do it slowly, we can see what's going to happen here. I've got my 4 and I'm multiplying it with a p. So I'm going to get 4 times p, or 4p. Then I'm going to take my 4 and I'm going to multiply it with a -2, and I'm going to get -8. Maybe a better way of saying that is to, after you've multiplied 4 with p, you get 4p. Then you say minus, because that's the sign operation that's in the bracket. And then you say 4 times 2 then is 8. You'll still get, of course, the same result. And then on the other side, I'll do the same thing. I've got 5 times p, which gives me 5p. And then I've got plus, and then I have 5 times 1, which gives me 5. So now at this point I'm back to having something like this. See, that's basically the same setup there, and that is what we wanted. When we were here, when they started off, we had our terms sort of locked in these brackets, and by multiplying into the brackets I've sort of unlocked it, and now I can deal with it better. Now I can take the numbers to the right and the letters to the left like we did in the previous one. So if I do that, I'm going to say, okay, I've got my equal sign in the middle, I've got my 4p here in the right place, my 5p is positive, so I'm going to move it to the left hand side. I now have, if you can maybe just use a different color here, I now have it as minus 5p. Then on the right hand side, now remember there's a -8 here that we're going to deal with now, so don't forget about the -8. So on the right hand side I've got number 5, the 5. Remember the 5p is now already moved away, but 5 stayed. 5 is in the right place. But if I'm going to move the 8, the -8, remember this 8 is negative, I'm going to move it to the right and it will be plus 8. Let me just use the blue there. That will be plus 8. So that's 5 plus 8. And simplifying this, we have 4p minus 5p is -1p, or -p. And 5 plus 8 is 13. And at this point, things get a bit weird or confusing, because we're not always used to seeing a negative variable here. We know that we're solving for p, but now we've got this annoying -p, and we don't want -p, we want p. But some of us forget what to do here, so we just tend to leave our answer like that and move on. In which case it's wrong, because we weren't asked to solve for -p, we were asked to solve for p. So we need to get rid of the negative. And remember, the negative is actually -1. The coefficient here at the moment is not 1, it's -1. So I always want my coefficient to be 1, which indicates that I've solved the problem. So what do I do to get rid of my coefficient? The same way that I've divided by 2 here, because 2 was my coefficient, I need to divide by the coefficient here, which now is -1. So I will divide both sides by -1. And what does that do? Well, that gets rid of the -1 and leaves me with p. And 13 divided by -1 is -13. So my answer is -13.